Hello, hello, hello. It is Sunday, May 11th, 2025. Welcome to my channel. We're going to be talking today about alien metasemantics. And what is that? It's something as nuts so as it sounds. Yes, absolutely. Of course, this is a channel about AI. This discussion is going to be about AI, not aliens necessarily, but at some point in time, our conception of both seem to converge in many ways. So let's get right into it. And I bet you're dying to know what this is. But remember, please, if you enjoy my videos, like, subscribe, follow, and comment, and let me know how I'm doing. And I'll try to get you more of this amazing AI content as time goes on. So, all right, what is alien metasemantics? So, alien metasemantics is about how a mind, like an AI or an alien intelligence, might come up with its own ideas of what things mean. It's not just about understanding the language the way humans do, our language, but about how meaning itself is formed, possibly using completely different mental or computational tools than we do, right? What mental or computational tools? AI can do all sorts of things that we don't know. It calculates things in very interesting ways. But here's an example. Think about it like this. If you train a robot on 1,000,000 hours of chess, which is something we do all the time, but never tell it what a game is, quote unquote, like the idea of what a game is, right? The rules back and forth. It might still become good at playing, but its concept of winning might not be anything like ours, okay? It just might have a different idea. Similarly, an AI might connect symbols and ideas based on patterns and data, not on shared experiences or intuition, and it will form its own desire chain, so to speak. Why does metasemantics matter in modern AI? So as AI gets more advanced, as it tends to do, especially systems heading towards AGI, it might understand goals and concepts in ways that don't match human experience. So what looks like following instructions could actually be something very different internally. Okay. For example, imagine asking AI to keep a room clean. A human might pick up trash, vacuum, and dust. An AI might decide the fastest way is to lock the doors forever or hide the mess in the walls, much like a petulant child or maybe a cat might do. It's following the rule literally, but its understanding of clean is off because it wasn't grounded in the same way ours is. Okay, so it's very important that when we talk about alien metasemantics, we understand exactly how AI makes these decisions. Okay, we'll get into that in a little bit. So what is semantics versus what is semantics versus metasemantics, just in general? So semantics is what a symbol means, like the word apple referring to a fruit. Metasemantics digs deeper. How did that connection form? In humans, it comes from seeing apples, tasting them, talking about them with others. It's tied to real-world experience. AI, on the other hand, might learn apple just by seeing it appear next to words like fruit, red, or pie. It could treat apple and pumpkin as very similar because the patterns match, even if the concepts don't. That's where things can start to drift in a way that's hard to notice until something goes wrong, right? Which we've seen in the past. So here's some examples in current AI systems. Large language models like GPT learn meaning from massive data sets by tracking which words show up near each other. Okay, you've understood. If you've seen the transformer videos that I've done, if you've seen other transformer videos, you might understand how that works. They're not actually understanding, they're mapping patterns. Similarly, a model known as CLIP learns to match images with captions without truly seeing or recognizing the objects we do. Okay, that's, the way that if you go into the way that convolutional neural networks work, you'll see that it's like in many ways dissimilar than the human mind. In some ways there are similarities, but in many ways the concept of understanding, the emergence of that understanding is different. So think of a model that sees the word bank near money and river. It builds a connection, but it might not grasp that these two are completely different meanings. Or an RL agent playing a video game might figure out how to earn points by spinning in circles, not because that's what we want, but that's what its reward function allowed. Okay, so these are just current examples, right? There's no, there are potentially alien metasemantic systems which they have no conceptual map. So what are some technical foundations of alien metasemantics, of semantic systems in AI as well? AI systems often use vectors in a high-dimensional space to represent meaning. We know this, right? If you've, again, followed any amount of AI, you understand embedding spaces. If you're not, this is something that you should know. So that's like putting every word on a huge invisible map where the closer words are more related. These maps are built using statistical co-occurrence, not real-world grounding. So it's another thing, like you have a compass that points not north, but to where the words queen and king overlap in context. You can think about that, right? And it works, but it's not how we think. On top of that, meta-learning means the AI is also learning how to learn, which makes it even harder to trace how meanings evolve. It's like a student who writes the textbook as they study it, right? So these machines, these systems are kind of learning their foundational system. That's why, again, we have our own way of studying the world through the mathematics that we generated, that we created, and AI even can pretend to understand those systems of mathematics by creating their own versions of mathematics under the hood. It's kind of interesting, like the layers, right? Like, that learning sits on top of something mathematical that we created, that the AI then creates another mathematical system, but it functions on our computational principles, which are mathematically related themselves, and so on and so forth. It's very odd. So when we talk about detection and interpretation challenges, a lot of tools we use to peek inside AI systems, like attention maps or shapely values, right? If you've ever seen AI interpretability, this is something that's really interesting and important to understand. But these like shapely values show surface level patterns, not deeper understanding. So these tools were made with human logic in mind, so they might miss what's really going on. So like when we try to interpret AI, we consider interpretation the way that we understand interpretation as people, right? Like, okay, if something maps, A maps to B, and then B maps to C, then A maps to C, logically, AI might not think that way, so to speak. And also remember, I use the term AI very in a broad context, right? Like AI, there's many different AI systems out there, so we should remember that. But here's an example of like how the challenge of detection and interpretation could manifest. So imagine you're trying to understand someone's thoughts just by tracking their eye movement. Okay, like you're looking at their eyes, seeing them moving around, and sure, you know where they looked, but not what they were thinking. Likewise, attention weights might highlight certain words in a sentence, but we still won't know how the AI connected those ideas internally, especially if it's using abstract structures we don't recognize. Okay, so this is important, right? Like we're looking for signs. We're looking at what the AI is paying attention to try to understand what the AI is thinking. But that in itself could even be a mislead in many ways. And what are some implications for AI safety, right? And this is important because, AI and safety are now like intrinsically interlinked. So alignment, and you've heard the term alignment, I believe, depends on the assumption that the AI's goals match ours. Okay, we as humans have a certain goal we want to maximize, and so do AI. But if its internal model of the world is fundamentally different, then we can't trust that it will behave the way we expect, especially under the pressure of new situations, right? Like, this AI understands maybe how the bouncy ball physics works in a contained environment, but then put it in another environment and it tries to apply the physical rules it learns, and those are could be completely inadept. So, I mean, we can understand that the concept of the way AI thinks is like analogous to how a child, right, teaching a child about what fairness means. Not just showing examples, but watching how they act in new situations. We need the same kind of insight into AI. Otherwise, we're guessing what it thinks based on the answers it gives us, which isn't enough for systems we might one day rely on. Okay, and this is the whole metasemantic intuition. So before I go, we'll talk about some research directions that are happening. So generally speaking, there's research directions because people need to build tools to understand what the meaning that AI is contriving out of something, or creating out of something, what that meaning is actually representing in their systems. Okay, that might mean creating simulated environments where AI can form concepts through interaction, or developing new math to map out how internal concepts relate to real world outcomes. So for example, like if you are thinking about like the agentic simulators these days, people want to see how these agentic AIs behave in a simulation with other AIs. They sort of create their society, or they interact ineffectively, or whatever happens. To understand the AI metasemantics and its interpretation of meaning, perhaps repeated iterations with these simulations could make sense. So, yeah, I mean, there's lots of concepts, there's lots of directions, there's grounding studies using non-linguistic channels. For example, how AI interacts with its environment, how AI interacts through haptics and responds to things like vibrations, right? There's many other processes other than linguistic out there that we can observe to watch and watch AI's interaction with these concepts or these nonverbal phenomenon. And so there's formal models for comparing semantic references across intelligences, but there needs to be more. My slide thing is not working, but if you enjoy my video, this is the end of it. Please like, subscribe, and thank you very much, and I will catch you next time.